How are you?
I'm fine, thank you. You too, I hope.
I'm also almost well.
Толь, подожди, давай, я начну это самое. Друзья, я сейчас формальную процедуру включения, я включил запись и формальную процедуру запуска конференции. Жак, I do formal procedure of launching conference, launching webinar in Russian. If it's very short and
go ahead.
Well understandable for everybody, for everybody. Друзья, сегодня у нас 24 марта 2021 года, сейчас 16 часов 3 минуты, и мы начинаем очередной вебинар зимне-весенней сессии семинара Климова-Зателепина. Today we will hear the presentation of Jак Руэ, President of French Society of Nuclear Research in Condensed Matter, and one of the organizers of French conference RNBE 2020, Réaction Nucléaire à Basse Energie. This was a formal announcement about this conference. I ask everybody, and Dmitry Baranov especially, to switch off microphones. Everybody, please ask you switch off microphones. Only organizer and only Jacques Rué don't switch off. Another person please switch off. It's very easy to do that. Бушланов не слышит, Петр Захаров не слышит, Болдырева не слышит, я выключаю.
Валерий Николаевич, включите изображение Бушланова.
Бушланов, выключите, пожалуйста, свой звук. Я вас выключил. Вам звук не нужен. Вы будете все слышать. Только ваш звук мы не будем слышать. Вам он сейчас не понадобится.
Я ничего не вижу.
А сейчас ничего и не... Продолжает. Интересно. Я не могу здесь ничем помочь. Я тут ничем не могу помочь. We continue our work of our webinar. And Jacques, I may say that we hear the short review of paper presented on RNBE 2020 on December of last year, and it was done by Tsvetkov and Prosvernov, participants of our webinar. But I think that it's worth to repeat this short review in executed by you you president of French society, and you one of the participants of this RNBE 2020, and it will be possible for us to speak second time to hear from the participant of this conference. Jacques, please show your screen and you may begin your presentation. You have 60 minutes.
60 minutes, thank you very much. It's much more than I need.
Every time you want, maybe 30 minutes, maybe 40 minutes, up to 60 minutes.
No problem. I hope if you have questions, I hope I shall be able to answer. May I share the screen? I cannot do it now.
Sorry, I will do that. Sorry, excuse me. I gave you permission to switch off.
Okay.
To switch on your screen.
Thank you.
It needs to wait a little, a few,
yes,
1-2 minutes, because it will take a time to switch on your screen.
I don't know if you see anything.
We don't see. We don't see. Try please again to switch on. Maybe once again to push the button of green button.
Может быть, Просвернов поможет.
Ну, не знаю, да.
Green button. Green button.
I know, but it does not work.
Жак,
Just a moment. Don't worry. Desktop, iPhone.
don't be excited. Be calm. No problems. We will wait. Jacques, one more attempt. Maybe you should push not only on the middle, on the central point of a green button, but a little bit right part of this button. Some arrow on the right part of this button is. Maybe please push on this arrow.
Yeah. I know. Qu'est-ce que c'est que ce truc?
Jacques, your PowerPoint must be work before.
Александр, дело не... Он вообще экрана показать не может. Вот в чем проблема.
Может, у него проблемы с интернетом?
Алиса, goodbye.
Нет, его видео очень хорошо просматривается, никаких проблем с интернетом у него нет.
До связи.
Да.
Я думаю, ему нужно выйти из этого самого, еще раз войти, может быть. Вот.
Да, у меня сегодня были проблемы с динамиком, пришлось перезагружать компьютер.
Ну, да, такое возможно.
Problem is, this is the first time I use this computer with Zoom. And I guess I have a problem of configuration.
Sorry. May I give you an advice? Maybe you should exit from this Zoom, restart your computer. Restart. We will wait. Don't worry. Exit from Zoom, restart your computer. After that, enter to the Zoom once again. It will help, I believe.
I agree. I'm going to do that. I'm just back. Okay.
Okay. Please switch. Go exit. Please exit from Zoom and okay. Он вышел.
Анатолий Иванович, как самочувствие?
Спасибо большое, Александр, так сказать, но уже гораздо лучше.
Ну, слава богу. Так держать.
Надеюсь.
Ну вот я советовал Анатолию Ивановичу и всем посоветую. Я же ведь это все... Вот Жак Руэ снова попытку делает войти к нам. У него быстро компьютер перезапустился. Ну вот, я прошел эту процедуру, которую Анатолий Иванович прошел, а именно болезнь. Я, кстати, во время болезни вел 26-ю конференцию вместе с Просверновым. Саша мне помогал. Вот, если бы не он, я бы там, наверное, прямо перед микрофоном бы и, так сказать, сознание потерял. Но он мне помог. Вот. Но после этого я 2 месяца откачивался, отходил. Поэтому, Анатолий Иванович, 2 месяца у тебя впереди. И даже не старайся там по лесам бегать, как ты любишь. Так вот. Жак Руэ here. But, no. Jacques, I see
Yes.
that you are here, but we don't see you. Maybe you switch on your video to see you and try once again. It's okay, Jacques.
It's okay, except what?
You are succeeded in this. You are succeeded. Very well. Start, please. We hear you.
I am here, but don't worry, I have a small problem now because I need to load the presentation. I am using the old computer.
You use another computer, yeah?
Yes, this one is working. And but
see by post, by email, your presentation from one computer to another.
exactly what I am doing.
Yeah, we are waiting, don't worry. We are waiting, don't worry.
Thank you. Ah, misère.
In Russia, we called this situation visit effect. Everything is going well until the time when you need to visit somebody to your laboratory. When somebody visit to a laboratory, no apparatus, no devices working in laboratory. Visit effect, it's called in Russia. Jacques, may I give you another advice? It's better for you to return to video of yours, not presentation. Switch off presentation, and switch on video. And first to launch your presentation on your computer, and after that switch on screen demonstration. Sequence of action should be.
Валер, он просто не выбрал не то окно.
Ну так я ему про это пытаюсь сказать. Жак, please do what I advise you. First, switch off, push the red button on your screen. Red button, switch off your presentation.
Yes, I did it.
No, you did. We see your screen. After that, switch off your presentation.
No, but the presentation is not on this computer. This is the problem I am going to fix.
Okay. We wait. Okay, no problem. We wait. Но у него не на этом компьютере. Он с другого компьютера переносит презентацию на этот компьютер. Вот, поэтому это некое время. Друзья, ну потерпите, пожалуйста. Он очень волнуется, это видно. Вот, поэтому давайте потерпим. Так?
I'm really sorry for that, you know. But indeed, just as an introduction, do you hear me?
Yes, we hear you.
Okay.
But we don't. See, we don't. We see your we don't see your presentation now.
No. I know. It's a chance you gave me 50 minutes.
50?
Ah, okay, it's coming. Ah. Do you still see my screen?
Jacques, we don't see your presentation. My advice is.
No, but do you see my screen?
Yes. We see your screen.
We see
It's a very big file.
That's all.
Very big file.
Excellent.
We see that he is dumped into another computer.
Yes, this is the old one. This one is used to Zoom. The new one, this is the first time I was attempting to use this Zoom, and you need some setup, you know.
Oh.
Victory.
Beginning of PowerPoint. Oh, okay. Jacques, we see your presentation.
Thank you very much. I am really sorry for this 20 minutes of delay, but you know.
Okay.
Don't worry, it's normal. I gave you 60. You remember?
Yes, yes, yeah, I don't need all that.
20 less than 60.
Okay, thank you very much. So thank you very much first for this invitation. You know, it's very kind to you. I appreciate this opportunity to exchange some information with this group in Russia, because you have a long history on this in this science, and it is always worth to discuss together. In France, we are a small association dealing with this subject, but in France, you know, this is a rather small country, at least on this matter. And we organize a conference every 2 years, basically. We had the first one in 2016 in Avignon, a second one in Paris in 2018. And the last one was in last November via, of course, WebEx virtual conference because of this COVID problem. During this last conference, we had 11 presentations in total. Some of them, I don't need to present them because these are dealing with general reviews, you know, of this LNR cold fusion subject. And I noticed in past conference, in looking at your past conference, that you do it very well as well, if not better. So no need to discuss this, what we presented in Paris. And we could discuss as much as you want later about these European projects, and also maybe more interesting experimental results. And these are mainly the 3 presentations I decided to present this afternoon, with some more dealing with theories, you know, but this is highly specialized, and I would not be able myself, I am not a theorist, to present a presentation on theories. Anyway. So first, this European project, Clean Chemie, it stands for Clean Hydrogen Metal Energy. Last year, 2 years ago now, the European Commission launched a call for proposal for breakthrough energy technologies, and including in these potential technologies, it was mentioned, you know, metal hydrogen energy. So we decided two projects decided to submit an offer, and several projects decided to propose something, and 2 projects have been financed. So the first one, this is Clean Chemie. It gathers 16 partners with the leader from Szczecin University in Poland, but also Marine University in Poland, the CNRS, this is the French National Research Center in France, Politecnico di Torino, and so forth, including a university in Canada. This is not in Europe, but still these Canadians were allowed to join this project. And also 6 companies, Sart von Rohr, this is an equipment supplier in France, Vegatech, a specialized company, a company specialized in fluid, let's say, control equipment, and also some others, you know, with a budget of 5.5 million euros. And the objective of this Clean Chemie project are very ambitious. This is to develop a new source of energy based on hydrogen metal energy, but also something very important, to develop a theory to explain these phenomena. Indeed, the project leader, this is who is Konrad Czerski in Szczecin, in Poland, has some ideas regarding these theories, especially based on the screening potential of metal lattices for proton and deuterons, which may enhance by many orders of magnitude these the probability of fusion between these light atoms. And this is investigated by accelerators driven at very low energies. There is one such accelerator in Szczecin, and they are using it. There are others also in Germany. They want also to replicate the results already published on nanopowders with gas loading experiments, and to go further to develop other active materials. So this is a 4 years project, and 9 months already elapsed now since the beginning, that they are still striving to develop a theory and new active materials. This is not an easy task, for sure. The second project, this is Hermes, gathering only universities and research centers with a leader in Peja-Pelko at Turku University. This is in Finland, but gathering also the workforces of Technische Universität München. CNRS, another laboratory from the CNRS again in France, Ndro University in Czechia, the Imperial College in UK. This is quite surprising because of the Brexit, you know, the United Kingdom is no longer part of the European Commission, but still they are involved in this project. And Limerick University in Ireland and Aalto University in Finland, with a budget of 4 million euros. And the objectives, this is to study in experiment and on computer models the influence of isotopic effects in hydrogen loaded materials. Indeed, these people, they are specialists in, you know, in batteries, hydrogen metal hydrates, batteries, hydrates to store hydrogen in a solid form, and they are mainly interested to join this project to gather more, let's say, understanding of the isotopic effect on these materials used for batteries and hydrogen storage. Indeed, they are going to restart everything from scratch with electrolysis, electrochemical experiments, both at room temperature and at high temperature. But also they want to focus on reproducibility of these results. And indeed, they don't worry very much if they don't succeed in making cold fusion, because for them, the largest interest for them is to obtain more information on the isotope effects for hydrogen, you know, storage in batteries and things like that. They are even able to make, as we call them, ab initio studies, ab initio calculations. This is, it means using computers to simulate just on computers, atoms and electrons and everything, you know, going around to see what happens in such and such cases. this is Imperial College is the capability to use these very large computer models. This is the Hermes project. So we had other presentations in this conference, and one of the most intriguing one was this presentation made by Frank Gordon and Harper Whitehouse from California, actually. And the title was a lattice energy converter. It was presented in French by Jean-Paul Biberian, indeed. And what did these people do? This is quite interesting because they made a discovery a few years ago. They wanted to see if it would be possible to ionize a gas using americium-241. And because indeed in the past, Frank Gordon and the colleagues were specialists in atomic or in radioactive batteries, you know, this kind of very small batteries using radioisotopes to produce small quantity of electricity, but at a very high voltage. So they were looking at this, but they used this with hydrogen and palladium. And they realized that they were getting much more current, several orders of magnitude more than expected from these, I would say, conventional radioactive batteries. And the current conducting was using this americium-241, but the sensitivity of the instrumentation was not enough to make a clear distinction of the current obtained. So they realized that this current was not coming indeed from the americium, radioactive americium, but from something else. And probably the palladium hydride itself is ionizing the gas, the hydrogen. Very surprising. So they made a very simple experimental like this, with two tubes, two concentric tubes. You are going to see a sketch of the internals later. But with internal tube covered with palladium and an external tube, ion tube around. And between these tubes, some gas, you know, hydrogen or deuterium, and just one electrode connected to the internal tube, another electrode connected to the external tube, in order to maintain the gap between these two concentric tubes. You know, number 7, you have O-rings, just rubber rings to maintain the distance. And thanks to that, they are able to measure a current, a spontaneous current between these two. So it's very surprising. You have two tubes. The inner one is covered with palladium. The external one is just a bare steel, if I remember. You put hydrogen or deuterium in this tube assembly, and you get some current. And they were able to measure this current with a very simple, you know, voltmeter like that, with a 10 mega ohm input impedance. In order to get a better assessment of this current, they decided to load this cell on resistors, you know, adding 10 kilo ohms each time in parallel to see what was happening. And you see indeed that if you decrease the resistance, of course, you increase the current, but you decrease the open cell, the cell voltage. You exhaust indeed this very small generator. With 10 kilo ohms, you have a very small voltage. So this is not a very powerful generator, but still the fact that it generates current spontaneously, it's quite surprising. They observed something else. They decided to heat up a little bit these tubes. And you see that the temperature was going from 295 Kelvin, 20 degrees Celsius, sorry, to 340, 70 degrees Celsius. And you see that this voltage went up from 8 millivolt up to 200, 300, 400 millivolts. Right? Interesting. The fact is that this voltage is not stable. You get spikes and bursts and variations and fluctuations all the time. So this is not a very smooth and stable electrical generation of electricity. In order to have a better look at this phenomenon, they decided to set up a different experimental system like this. You have in the center this palladium electrode. This is a tube covered with palladium on the outside surface. The outside tube now is much larger. And between these two tubes in this gas space, you put an assembly of foils, of fins, alternating between zinc and copper. Zinc, copper, zinc, copper, zinc, copper, zinc, copper. You connect all these zinc electrodes together, all the copper electrodes together, and you measure now the voltage between the zinc electrodes and the copper electrodes. And by the way, you also monitor the voltage between these palladium central tube and these copper electrodes, you know. And as a gas, you use hydrogen or deuterium. And hydrogen or deuterium at atmospheric pressure, you know, just atmospheric pressure. No need for vacuum or pressurizing. And this is what they get. The temperature, they change the temperature along this experiment, but between the zinc fins and the copper fins, they got connected to a 10 megaohm again voltmeter. They got 0.2 volts, 200 millivolts, while between this copper and the central palladium covered tube with this is a 5 megaohm voltmeter, they got a negative voltage. Jean-Paul Biberian, you know Jean-Paul Biberian, this is a Frenchman. He is the guy who made this presentation on behalf of Frank Gordon during this seminar for the French Society. But he was aware of this experimental work, and he decided to replicate it. Exactly the same thing with a central tube of palladium inserted into a stainless steel tube. All that with hydrogen, light hydrogen, not deuterium. And he got something between 300 millivolt and 500 millivolt again. So this is not a purely American phenomenon. We could replicate it as well in France. During the same conference, someone else, maybe you know him, Fabrice David, made very similar, indeed, reported very similar experiments, again with spontaneous generation of electricity. So it was really a chance to have these two presentations in the same day. And this is in French, but it means a replication of direct conversion, you know. Fabrice David worked with, in collaboration with American partners in Florida during several years, and they developed what they call this fusion diode. What is a fusion diode? This is again an aluminum tube insulated internally by indeed a PVC plastic tube. And inside you put progressively, you fill up with powder, but the powder composition changes from between just palladium at the bottom and pure silicon at the top. So you have here, you have a lot of palladium, very little quantity of silicon, and here you have 50-50 palladium silicon, and here mostly only silicon and no palladium anymore. And with some valve to fill up with hydrogen or deuterium. In their case, this was mainly deuterium. And this is what they see, you know. The time here is in minutes, so this is 1 day, 2 days, and things like that. And the fact is, on my screen, okay, that's fine, sorry. You see the voltage obtained in argon, almost nothing. In hydrogen, light hydrogen, during these 2 days, a fluctuating voltage going up to 350 millivolts. And with deuterium, this is the yellow curve. I don't know if you see it, but something spiking up to 500 millivolts, going back again along the time. This is not stable, to 400 millivolts. With the same observation, you get a spontaneous voltage. It's not stable. It is clearly related to the interaction between palladium and hydrogen or deuterium. You get nothing in inert gas, so it's quite strange. But this is a monitoring during the first 2 days. But indeed, they kept these devices working during several months, as much as 11 months, if I remember what Fabrice David told us. And during all this time, these systems was producing a little bit of electricity. Not much, indeed. Huh? I don't know if you know Fabrice David. This is this man, very nice chap. Here is in Florida at this lab, filling up this tube with an hydraulic press, you know, making this very interesting experiment. Unfortunately, with no money to do this, so during some months, he was able to do these experiments together with this American company in Florida. But later on, the project was finished. And now, I guess he's not working anymore on this subject, except that he's still on his own making some experiments he reported in the same conference, developing, for example, what we could called these gas cells. What are these gas cells? They are made with glass, small gas cup. Inside you put some electrodes, not a copper grid here, indeed here a copper grid, and here an electrode made of copper with some palladium coated by electrolysis, electrochemical deposition. Here you have a tube, glass tube, to fill up, to make a vacuum or to fill up with hydrogen or deuterium. And these two electrodes you can connect to a voltmeter to check what is happening. And in hydrogen, he gets 50 millivolts, again, of spontaneous voltage. And again, this is at normal pressure. So what is the explanation for that? This is a figure adapted from what Fabrice David told us. In his view, we see that some electrons go from the palladium to the copper electrode. And it means that if the electrons go like this, you have positive ions, going the other way, obviously across the gas space. So you have some atomic or hydrogen ions in one form or the other, traveling from this palladium to the copper. And maybe one possible explanation is that any LNR phenomenon here on this palladium helps to eject these. Here is he wrote H2 plus molecules, why not, which are traveling all the way down to this copper electrode, and they recover here this electron, and it maintains the voltage between these two. This is a tentative explanation, but indeed it should deserve much more investigation. That's all for this, let's say, spontaneous generation of electricity in these gas cells with different electrodes, a very strange phenomenon. That's not all. In this same day, we had another presentation by the Institut Louis de Broglie. Maybe you know this name, Louis de Broglie. Is the guy who wrote for the first time the relationship between particles movement and wavelengths. And they made quite interesting studies presented by Gaëtan de la Chaise-Murel. Gaëtan de la Chaise-Murel, who is working at CEA, Commissariat Énergie Atomique in Arpajon. Indeed, he is employed by the CEA, but it does not mean that the CEA has any responsibility in the experiment I'm going to present in a few minutes. Is just allowed to work on his own at times on this subject. Okay, don't believe the CEA is deeply involved in that. This is not the case. So this group, indeed, they are looking for magnetic monopoles. Another French theorist, Georges Locac, who died 1 month ago, proposed in 1984 an equation to describe the lepton, what he called a lepton monopole, a very light monopole. Leonid Urutskoev, this guy made experiments with electrical discharge in water and to detect a particle which could be lepton monopole. So this Institut Louis de Broglie and this man from Syria collaborated with École Centrale de Nantes in France. This is a large engineering school to study again discharges in water, quite similar to what Urutskoev made some years ago. So this is an experimental setup in Nantes at this school. You see here a container where these electrical discharges are made. They collect the gas coming out after the explosion. They measure also the voltage during the discharge. And what are they doing? They are using indeed very similar to what Urutskoev did, a titanium piece with a 3 mm of conductor size in the middle, with larger piece for electrical connection. This titanium wire was placed in this container covered with polyethylene, plastic bag for electrical insulation. The water, after the explosion, the water was collected, the oxides falling to the bottom were also collected, but the gas also coming, generated by the explosion was also collected for analysis. And for this discharge, they have a capacitor bank of 400 microfarads. They can load up to 7,000 volts. Okay, with a switch here. And this is the kind of electrical discharge they get. The current here up to 40,000 amps. The voltage, in this case, 3,000 volts. And even the ground connection, during the discharge, the ground connection is not at 0 volt, because of this very large current. You have to take into account the fact that this ground connection is above, indeed, the 0 volt level. Energy, in this case, 2,220 joules within 80 microseconds, quite a large instantaneous power. They made several experiments like that, and they had the chance at CR to have this water, the water coming out of this container, analyzed to see the quantity of deuterium in this water. And maybe, on the Earth, you can have in natural waters, in the ocean, in lakes, in groundwater, in different places, in desert areas, different kinds of waters, which are enriched more or less in deuterium because of the evaporation, But the fact is, when you have an enrichment in deuterium, you also detect everywhere on planet Earth an enrichment in oxygen 18. So the ratio oxygen 18 to oxygen 16 is strongly related everywhere on Earth to this ratio deuterium to hydrogen. And everything you do should fall on this red curve. But in fact, at times, you get much more deuterium than normal. Even if you got some oxygen 18, you had too much deuterium. And at times, you had too little deuterium and too much oxygenated. So it means that indeed nuclear reactions were taking place during these electrical discharges. Quite interesting. They made also other experiments in an attempt to evaluate if there was some energy produced. So this one-shot electrical discharge to destroy titanium wire is not easy to assess if there is a production of energy. So they made a different setup, much smaller, in a glass container like this, with an electrode dipping into this water, normal water, and with discharges of 350 microfarad capacitor bank, charge up to a few kilovolts, I don't remember, and with some sodium hydroxide in this water to help the electrical conduction. So they have a nice electrical equipment to measure very rapidly and very high rate the voltage between these electrodes as well as the current flowing through these electrodes. And the discharges are indeed switched on and off via this MOSFET IGBT semiconductor. And they make these experiments like the following way. It's quite interesting. Please follow. The water is heated up by a heater at the bottom, you know, up to 100 degrees C. The container is well insulated, but it is put up to 100 degrees C. So the water evaporates, you know, slowly but surely. And you see here the quantity of water in grams. So this water goes down because the water evaporates slowly. And during some minutes, you know, they make many discharges. Maybe 100 to several hundreds of discharges in this small container. And indeed, they say, they see that the water evaporates much faster during these discharges than before and after the discharges, during the waiting time before and after. And should the electrical energy injected in this water by the discharges, it's easy to know what is the electrical energy input, isn't it? The water should go down that way because of this additional energy input. But indeed, we get much more. And we made sure also that there was no water droplets sent in the air, you know, during these discharges, because the electrodes are dipping quite well in this cell. The cell itself is covered in order to avoid any water loss by these small explosions. We see some steam coming out, but we know that the steam is dry just by looking at the transparency of the steam stream coming out. So, frankly speaking, there is very little chance there is water lost by spitting out water droplets. And in spite of that, we see that the energy output is 1.9 times larger than this electrical input. I hope you followed me because it's quite tricky. Indeed, I have to admit something. I love this kind of experiment. And in the next pictures, I am going to show some other experiments I made myself with water discharges some years ago. So these are not things I presented during this conference on last November, but things I presented before. But as these are strongly related to what Gaëtan de la Chaise-Murel and Institut Louis de Broglie demonstrated, I could not resist this afternoon to show you also what I did a few years ago. This experimental setup works like this. I have a 5 kilovolt DC supply, and this electrode is operated mechanically by a system that alternately connects this electrode to a 0.0 microfarad capacitor, and at times connect this to the water to discharge this capacitor via this water. You see that I could monitor the voltage here and also the current here, but you are not going to see these electrical measurements because looking at them together with the friends from Institut Louis de Broglie, we came to the conclusion that my instrumentation for electrical measurement is not adequate. This piece of equipment nowadays is in the hands of this Institute Louis de Broglie, so they are supposed to make further experiments with it, with their very nice electrical instrumentation. But unfortunately, because of the COVID problem, you know, nothing is happening for the moment. But I hope we are going to renew these kind of experiments in the near future. So these are two examples of what you see when you make such electrical discharge in the water. This is the moving electrode, you know, in two different discharges. Sometimes the discharge is like that. You just discharge a capacitor with a small arc above this water, and you see a nice arc, a nice spark, and nothing more. Sometimes it's quite different, and you get a very violent explosion. And I am going to show you some examples in a few minutes. But at times you get this, sometimes you get that. And it is also a problem in this case because they know that when they make many discharge by triggering this MOSFET, at times they don't always get the same kind of explosion. This is the same problem. So this is what I did. For example, you see here an explosion, a small one, an explosion, a miss. Here again an explosion, a small explosion, a miss, an explosion again. Different electrodes, you know. When you have an explosion, the water is thrown in the air. I'm going to show you a small spark, a small spark, a small spark. Here an explosion, here a small spark, and so forth. An explosion again, and here an explosion, and here a strong explosion. You see, when you have some explosions, they might be very strong. And we can compare what is happening in these different cases, you know, because you have seen I made some movies of these experiments, and we can compare frame by frame what is happening between a gentle spark and a water arc explosion. This is at the moment of this explosion. In this case, you see the spark on the very calm water. The counter electrode, by the way, is just a needle. Huh? And here you don't see anything because, you know, there is a very bright light, thunder. So at this moment, this is the situation. And 33 milliseconds later, most of the water is thrown in the air, you know. And you get a storm in this bottle when you have an explosion, while in the other case, nothing is happening, absolutely nothing. And it takes some time before the water settles again at the bottom. The electrodes now is moving up again. And that's all. So thank you for listening.
Okay, Jacques, thank you very much for your presentation. You took approximately 50 minutes, it's okay. And I ask everybody, я прошу всех задавать вопросы. Для этого надо вот поднимать ладонь. Вот там, Jacques, I explained for our Russian colleagues how
yes, please do.
How to put questions to you. Так? Вот. We have one question now. And я остальных прошу также, вот надо нажать на участники, клавишу участники, там справа будет, развернется полотенце, на котором можно будет нажать клавишу поднять руку. Значит, ну вот у нас есть, значит, первый вопрос. Это Просвирнов, Александр Просвирнов хочет задать вопрос. Александр, пожалуйста, please.
Jacques, one common question.
Yes.
What's your opinion and the opinion of your French colleagues? Is it Yakat of André Rossi is a real device or it is fake?
What device?
Yakat of André Rossi. Do you know Andrea Rossi?
Andrea Rossi, yes. Oh, this is an old story. We don't have many news from Rossi these days. Yeah. For me, I have quite. There is no official opinion from our organization, but at least I have my own views on that. Maybe Rossi really had something in hand when he was working together with his Italian counterpart.
Pocardi.
Yes. And based on that, he tried to make things larger and larger. And indeed, he went too fast. He could not control what was happening. And apparently, indeed, I guess he's not able to reproduce what he did, what he says he can do. It is also very strange to see that he switched from a so-called 1 megawatt power unit based on this ECAT, the original ECAT, to other things with the OTCAT and now the XCAT. This man is running ahead, and it's quite strange.
Okay, Jacques, no problem. this question isn't concerned to the theme of our webinar now. It's your report, and maybe somebody else would like to ask something concerning.
But, as you are asking me, what is of interest these days? I don't know if you are aware of what is being done in Japan these days.
I
What
don't
do you
know.
mean about Japan?
If you don't know, there is a company called Clean Planet. And if you look at their website, these people are now pretending to, they are hiring people to commercialize generators, heat generators. And these are heat generators, you know, developed on the technology, on the process made by Yasuhiro Iwamura, with this hydrogen loading and deloading from copper nickel multi-layers. So these people should deserve some attention, you know, maybe because they come from the university, the Oku University in Sendai, Japan, and they are progressively developing new things. We know, at least, they published some papers in the past showing that they do. Contrary to Rossi, you never knew what he was doing. Clean Planet, we know what they do, or at least what they did. So the interest could be now coming from Japan.
Thank you very much.
Thank you.
Okay, answer is, it was answered. Okay, Nikolai Magnitsky, put your question, please.
My question is, what do you think about existence low energy nuclear reactions? Are they exist indeed or not?
Thank you for the question. If you want my personal opinion, there is something happening for sure. We see a phenomena that cannot be explained by, let's say, conventional physics and chemistry. Now, do we see indeed nuclear reactions, or do we see other type of reactions, not nuclear fusion, for example, but other things? It remains to be seen. In the Clean HME project, they are clearly working on the hypothesis that yes, we have fusion, nuclear fusions of deuteriums and protons. But with some other experiences, it is not that obvious, you know. So this is a good question. And yourself, are you convinced we have nuclear reactions, or do we have other things?
Thank you.
What do you think, Nikolai?
Okay, another question of Magnitsky.
I don't know. From my opinion, there are no nuclear lower energy reactions. There are another reactions, I think.
This is the kind of reason why I love to talk to you in Russia, because you have different viewpoints, you know, points of view, and it's very interesting to discuss with people who have a different point of view. Because in Europe, we are all striving to prove there are nuclear reactions. Maybe there are not. So thank you very much.
Thank you.
Okay, thank you, Nikolai, for very interesting, very important. This question was interesting for Jacques Rué. Okay, Klimov, put your question, please.
Jacques, thank you for very interesting presentation. I have many questions for you, and I hope to write these questions in detail in my message. But now I want to ask you, what do you think about critical parameter of your explosion?
Water arc explosion? Or there is an interruption. But I guess the question was about water arc explosions. And indeed, I don't know, because we make many discharges like this, and you never know if the next one is going to be a small spark or an explosion. So what governs the explosion, you know? I noticed that if we put, in my case, I always use demineralized pure water. Okay.
Maybe.
While at Louis de Broglie, they use an electrolyte 0.5 mole of sodium hydroxide. Well, because after some times of operation, the water gets dirty. You don't see it's dirty, but you see more and more small spark and less explosions. And after that, after some minutes, you don't see explosions anymore. Just
and everybody see in your video of the dirty water with some of the nanoparticles of the process of erosion of the electrodes.
Of course,
it's very important.
Of course, of
yes.
course. And after some time,
and also very interesting results connected with the repetition of the Urutskoyev experiments. You told us about additional creation of the deuterons, and what's about another analysis for the isotopic analysis of the titanium foil? Do you remember that Urutskoyev give us information about chemical composition of the isotopic composition of the titanium foils? What do you have the mass spectroscopic analysis or maybe another analysis in this experiment?
No, unfortunately not. You know, these experiments, again, they are made with very small, let's say, laboratory capacities. They are made by small associations. Institut Louis de Broglie, this is a very nice name, but indeed, this is a small association, as we are. So they got the chance to make this analysis of deuterium and oxygen 18 almost for free. But only that. It would have been necessary to pay to have analysis of titanium and other chemical elements, and they could not pay for this analysis. Sorry.
Thank you very much. Thank you.
Okay. Thanks for questions. And last question, Dmitry Baranov put your question. Дмитрий, Дим, включи микрофон.
Все, включил.
Спасибо.
Можно, да?
Да, давай.
Жак, do you know that electrical discharge in water and electrical explosion in water, it's very dangerous for man. So there exists unusual radiation. And the experiment very dangerous. You know this.
I know that because indeed you, Russian, told us this. You are the only one who studied these strange radiations, and we have to thank you for this. This is the reason why, indeed, during these experiments, I was never in the same room as the discharge system. okay? It was working on its own automatically, but I was in the next room. Because you told me this is dangerous. And also, this is very important because these strange radiations, you know, each time I mention this to my colleagues, and they laugh more or less. I say, well, okay, but indeed, some other researchers, especially in Russia, found strange radiation, so we should be very careful with that. And it deserves much more, indeed, investigations for sure. So the only thing I know about these strange radiations are what you published yourself, mostly in Russian, unfortunately, I have to admit. And if you have any paper on this in French or English or even German, or would be very helpful for us, for me, because I thank you for your advice, Dmitry. And I remember the first time I heard about this strange radiation, this is Anatoly Klimov who told me about that. Since that time, I never forgot. And this is the reason why I would like to know more about this. In our case, these discharges are quite small, driven for a short time, a few minutes, and again, on a remote control. But still, we would like to know more about this. Thank you for this advice. So if you have any piece of information regarding these strange radiations, we would appreciate.
Okay, Jacques.
Thank you.
Thank you for the answer. And it was very important question. And Jacques, we sent you our joint paper with Dmitry Baranov about consequences of electrical discharge and influence on mouth and on other living feature on other living forgot English words on other living persons. Okay, thank you very much. We will send you a paper. And Bob Grenier, last question, please. Switch on microphone, Bob.
Bob, switch on.
I got you. Sorry, I was in a different window. I was actually trying to prepare something. Thank you very much, Jacques, for an excellent presentation, particularly on the water spark discharge. I think Peter Greneau did a lot of work on that. I shared a blog that I published a number of years back in the group chat, which you can go and see if you click on the chat button on Zoom. And it's the first there. And they created a water spark discharge by using an induction coil from a car and the diode hack, where you kind of like link one part of the coil to the top of a spark plug, and you get very, very intense discharges on a repeated basis. And then on one of the videos on that blog, they had a water mist creator going through a tube with the spark plug, and they were able to continuously produce the large explosion state. So you can see those videos, you can see how there's a number of items on there. Also, in one of the videos that I shared on that about 3 years ago, someone noticed a cluster plasmoid forming away from the spark discharge that looks to be of a similar structure to that published by Bogdanovich in 2019 subsequently, where he describes it as multiple toroidal structures in a crystal structure that is able to spin on their own axis and on the cluster axis and travel and translate or roll across surfaces. So I'm really interested because what you've done is very similar in a way to Parkhomov's woodpecker, and you're saying that you had a problem with controlling when you get just a normal discharge and when you get this big flash. Well, if you look at the blog that I've posted there, you can go and look at these videos, see how they've achieved it with simple equipment. And this should give you an ability at a very low cost to produce continuously the type of discharge that you and I would agree are the more anomalous type of discharges.
So thank you very much. Thank you very much, Bob.
Right.
So
it's the first link that I've given to everyone in the chat. And it also talks about the fact that I think it's MIT or Harvard, the first discharge was observed, I think, in the 1910s in water, like a water mist discharge. It's not a new phenomena, but more recent work on YouTube has actually been able to perfect a continuous process of this production.
Okay.
So,
okay, thank you, Bob. Bob mentioned about woodpecker installation, which were used by Александр Пархомов. Maybe, Саш, может быть, ты спросишь что-нибудь относительно эксперимента? Аналогичный эксперимент. Аналогичный эксперимент.
У него дятел был.
А это и вот Боб и назвал это woodpecker, дятел. Это то же самое. Так? Okay, no reaction from Bob Parkhomov. It means that all questions finalized, and maybe somebody would like to give.
Sorry, can I just ask one more? Did he have equipment failure, monitoring equipment failure when the explosions happened? Because when I was at the second link that I put there, plasma flow discharge, the work that we did in India with Suhas Ralkar, he had a very powerful three-phase supply. And when he had one of these blue flashes in this very large device, it ejected a large volume of water, but the entire three-phase power supply shut down and we had to restart. And I caught that on multiple cameras. Did you have your power supply or whatever affected?
Indeed, thank you for the question. In our case, the largest discharge was just 10 joules, 10 joules, so it's not very large. But indeed, it might very well be the reason why I didn't show these electrical measurements, because we found strange electrical measurements. With 7 kilovolts of, I use indeed 5 kilovolts of power input. We were measuring 30 kilovolts of spike. Strange. So is that real or an artifact, well, so is that an answer,
I'll be interested in what the Institute find when they get some time to use the apparatus.
Yes.
Thank you.
This discharge, it's really a mess.
Okay, and I see, Jacques, no attempts to raise hand to give remarks. It means that no, everything is very understandable from your presentation, and everybody is well understood everything. No remarks. Please, maybe you could give some final remarks.
Yeah, so again, thank you again for this invitation. As I said, it's always interesting to exchange with different groups, who have different points of view, because if we keep between ourselves, we just repeat each other what we think and we said since months or years, while we might need to read different things, to think at different models, different phenomena. And this is the reason why I guess it is interesting to discuss with you as a Russian group, because you have different experiences, you know, different competences, and all together, the collaboration could be very fruitful. This is what I would like to say.
Thank you, Jack. Jack, I could mention that now in your presentation, it was presented people from Russia, from Kazakhstan, from Armenia, from Ukraine, from Alexander Nadezhdin waving his hand. He is in Israel now, but he is from Canada. And Bob Grenier from Czech Republic. You are from France. And it means that you are absolutely right that this is a way, such kind of webinar, this is way to join brains of scientific from many countries around all of the world. Thank you very much for COVID situation.
So thank you very much again for the invitation.
Okay, thank you.
Bye.
Friends, it means that we close our webinar. Thank you very much, and until the next Wednesday. Thank you very much.
Thanks a lot. Bye.